Alright, welcome back to Mathiad Institute, where we do all things computational. Alright, previously we just calculated the fraction of the day that is engaged in useful work, isn't it? Which was 0.5, or the probability of 0.5. The second question, which was B, is expected number of units in the queue. Alright, the expected number of units in the queue, alright, and expected waiting time in the queue. So here we are using number of units in the queue, then there's another part, expected waiting time in the queue. Alright, so we go back to our formulas, which we need to memorize, right? So for purposes of demonstration, I just want us not to get lost. So we're going to use the table in the video, isn't it? Alright, so where are we going to find the average number in the queue, or number of units in a queue? Already it has been circled here. Okay, average number of units in a queue. You see how simple it is. So just get this particular formula. So you are saying lambda squared over mu, open brackets, mu minus lambda. Alright, and that is going to be your average number of units in a queue, right? Now, we have already found our mu, or our average service time, and our average arrival rate, isn't it? So we just get to be replacing those things that we calculated. Alright, so we know that our lambda is, or our arrival rate is 7.5. Then that means it will be squared, isn't it? Divided by our mu, which is 15. Our service time, which is 15, open brackets, service time, which is 15, minus 7.5, right? We say equals, and what will that give us? Alright, so that will give us 7.5 multiplied by 7.5 will give us 56.25. Then 15 minus 7.5, that gives us 7.5, isn't it? Alright, we continue to simplify it even further. 56.25 divided by, on the denominator we know that we have 15 multiplied by 7.5, isn't it? So 15 multiplied by 7.5 gives us 112.5. Then 56.25 divided by 112.5 will give us 0.5. So basically that is our average number of units in a queue, right? Quite simple. And if you have any particular question, please you ask in the comment section, inbox me, so that we deal with any problem that seems to be problematic. Alright, we continue. What does the other question say? We calculate. So after calculating the quantity or the units in a queue, then we get the expected waiting time in the queue. Expected waiting time. So if we are going to the formulas and we want to find the expected waiting time, which formula would we go for? If we want to get the average waiting time in the queue, which formula do we go for? This one, isn't it? Waiting time in the queue. So basically, we've already, it's, the language is clear. So we get that particular formula, which is gonna be waiting time in a queue is equal to alright, Alright, that's our formula. We proceed. Our lambda, we know that our lambda is 7.5 divided by our mu, which is 15, open brackets, 15 minus lambda, which is 7.5. Alright, we close. We proceed. We know that this is 7.5 divided by 15, open brackets, 15 minus 7.5, that will give us 7.5. Alright, that would be equal to, again we proceed. We know that 7.5 will be 7.5, then 15 times 7.5, that gives us 112 point what? So let me just calculate. That is 15 by 7.5. That is 112.5. Alright, then we are now saying 7.5 divided by 112.5. That will give us 0.007. Alright, actually let me write it properly. What's this now? Alright, needed to erase this. Okay, that would be 0.06. This is 0.67. Alright, that is hours. These are hours. Alright, this number would make more sense if you convert it into minutes. That is basically just by multiplying by 60, isn't it? So if you multiply that number by 60, you know that you're going to get 4 minutes. Alright, so, but since hours are standardized units, so we're going to use hours. Alright, we go to C. We go to C. That was B. Now we go to C. What does C read? So C, expected number of units in the system. Alright, expected number of units in the system. So we go to the formula again, expected number of units in the system. Right? Expected number of units in the system. Alright, which is lambda minus over u minus alright, we are here. So we are saying units in the system. So we have lambda over mu minus lambda. So we know that lambda is 7.5 divided by mu, which is 15 minus 7.5. We know that we are going to have 7.5 over 7.5, which then gives us 1. So basically you have one person, or you have one phone call on the line. Alright. We proceed. Is that the end of that question? Let's see. Expected waiting time in a queue. Expected number of units in the system. And E, expected waiting time in the system. Alright, that's the last one. Let's go expected waiting time in the system. Basically, we know that this is the one. Expected time in the system. Alright, which is 1 over mu minus lambda. Alright, which is going to be, okay, So what did we say? Expected time is going to be 1 over mu minus lambda, isn't it? Lambda. Alright, so 1 minus 15, 1 over 15 minus 7.5. Alright, and what does that give us? So that would be 1 over 7.5. And what is 1 divided by 7.5? That would be 0.1333. Alright, and there we go. So this is the basic nature of queuing theory. Alright, then as we go on, we're going to actually find a little bit more complex levels of queuing theory. But overall, as I wind up, we are saying that queuing theory is just basically an observation of queues in the interest that we optimize them, right? That is the whole reason why we study queuing theory. We study queuing theory in order to optimize our waiting time and our service time. Alright, we want to reduce that time as much as possible because time is a limited resource, right? Since time is a limited resource, we want it to optimize it as much as we can. Alright, so that we can do as many as things in the limited time that we have. Alright, and we can apply this particular theory in a lot of different things, and we said telecommunications, in the banks, in the financial institutions or financial sector. You can apply it in the road system and infrastructure. You can apply it in the military. You can apply it in your business. You can apply it in agriculture. You can apply it in so many different things. All right, it is applicable in a vast space of things, and you need to master it because it will help you not only to pass your exam but also to be able to apply it in your individual respective lives. Alright, see you in the next video where we are going to upgrade the standard from the minimum which we were looking at into a little bit more complex explanations.